So hello everyone. In this video, I will show you how to create any circuit in the electric tool, and then I will show you the simulations on the LT Spice tool, where I will show you about the DC and transient analysis, and then after that I will make you familiar with dot param and the dot step command to sweep the variable, and then after that we will try to see how to achieve a equal rise and fall time in the case of inverter. So let's start. So this is our electric tool software. Look, where you can first you have to create a library to make yourself. So let's create a library. Let us name it as inverter. Then I will in the explorer it will get created, as you can see, inverter. Now I will create a cell here. I will create the cell name as inverter. So because we are going to make the schematic, you can select the schematic. If you are going to make the layout, you can select layout. But I am going to make the schematic, so I am selecting the schematic. That's okay. Now in the components, you will see the components. So let's make an inverter. You can click on the PMOS and press and drop your cursor and put here. You can press on the NMOS, click on NMOS, and then click on here where you want to place. For zoom, you can press Control and scroll up, and for zoom out, you can press Control and scroll down. So our PMOS and NMOS get created here. For to make the wire, left click on where you want to start wire and right click where you want to drop the wire. It will get automatically created. Left click where you want to start and right click. Now I will place the source. This is VDD supply and this ground supply. I will connect them. Now I will make the pins input pin and then output pin. Connect them also. Now I will place a load capacitor. So I'm placing a capacitor for the load and connecting it. So to change the value of capacitor, double click on this and let's say I'm making it as 10 femtofarad. And you can change the value. And to change the value of the PMOS and NMOS, double click on that and change the value. Let's say I'm making it 1.9. Sorry, NMOS 1.9. I'm making both them equal. So to move further, you have to export the pin. So create export and name it as VIN. It will get VIN label get created, and here you have to export the V out. And now you have to create the supply model for the PMOS and NMOS. So click on PMOS and go to tools, simulation spice, and then set spice model. And click on the NMOS, go to tool, simulation spice, set spice model. Now the library which I am going to use, I am showing you the library which I will use for this. So this model library, model file I will use, where the PMOS and NMOS both are parameters are given, and NMOS is named as NMOS here, and PMOS will be named as PMOS. So I have changed the name of in the spice model, and you can see the other parameter of both the transistors. So I am changing here the name. To change the name is here you can select it and go to edit and properties, object properties. Write it here PMOS. Click on OK. Click here, edit properties, object properties, and write it as NMOS. Click on OK. So after that, we have to now create the spice code. So for that, click on miscellaneous spice code, and after a box will get created and put it at anywhere, and then click on it and go to object properties, and select the multi-line test, because we are going to write the multi-line test here. So here we will basically write the simulation part, how we are going to include our library and how we are going to give the input and outputs. So first include our library. I will include dot include command dot include Then I will write the path of the library. So my library is in the D and D drive. Then it is in the VLSI folder / and its name as model files. Next, I will write down as about the VDD. This one is VDD. Wherever you put this source, this round one, it will be named as, it will automatically VDD get named as VDD. So I will write VDD and VDD level on the VDD, and then I will assign a value for it, and the value is low level value 0, and DC with delay 0, sorry, and DC value, and then its value as 1.8 volt I'm giving. Then I will give the input. For the input, I will assign V in. Here, the name of the voltage should be start with V. After that, you can write it anything. So V in, I'm writing in the port where you want to give V in and ground. This one is named as VDD, and in between VDD and 0, and DC voltage of 1.8. Here it is a V in named between V in and 0, and here I'm giving a transient, a pulse. So pulse from 0 to 1.8, low voltage 0 and high voltage 1.8 with 0 delay, and 100 picosecond of rise time and 100 picosecond of fall time, and then 5 nanosecond of on period and 10 nanosecond of total period. Now I'm going to write transient analysis I'm doing. So dot tran and then 100 click on OK, and then our model get created here. So go to tool, check DRC now. So I'm checking the DRC here. You can see no error found. So I will now write the spice file. Write spice deck, go to tool, simulation, and write spice deck. It will show here, and I will save the file. So our SPI file will get created. Now I will use this SPI file in the LT spice.